So in this video, we're going to be talking about the different ways that you can solve a quadratic function. Now remember, a quadratic function is any sort of function that we're dealing with where we're multiplying x by itself. So it could be something that has a term with an x squared in it. Or it could be something with a term where it's x plus or minus some number and then squared. Or it could be an equation where we see two separate parentheses with x's in it. So when we're looking at these, the important part, I guess, that you're going to need to think about is what type of equation are you looking at? So I like to use kind of a flow chart to keep track of where I want to go. So I always start by asking myself, does my equation have a b value? Now when I'm talking about a b value, I am referencing the standard form equation, which you should already be familiar with. If you're not, you may need to go and check out what that is. And I'm asking, does it have that middle term with an x in it? If it doesn't, we're going to solve by square roots, which we'll get to here in a moment. Spoiler alert, you spend all of your time using order of operations. If it does have a b value, then we have to ask ourselves further questions, such as, does it have a c value? Meaning, does it have this term on the end with just a number and no variable? If it doesn't, we can solve by factoring. Now, I put a little note here. This type of factoring is not using the box method that you may be familiar with, or the guess and check method that you may be familiar with. This is just where you're looking for common factors. Again, we'll talk about it in a moment a little bit more in detail. If it does have a c value, then we ask ourselves one further question. Is the a value 1 or something with obvious factors? Meaning, is a 1 or is a 2, maybe 4? You know, simpler numbers. Generally, I like to say anything less than 5. I would include 5 in that also. If it does, then we solve by factoring, and if it doesn't, we go straight for the quadratic formula. So you really have 3.5 methods that we're going to kind of deal with throughout this. So we're going to start by talking about solving by square roots because that's generally the most simple way. So this is where we see that squared come in. So it could be something as simple as 5x squared equals 125. Now you saw me write down this. If you're not familiar with this acronym, it's your order of operations. Now when you're simplifying, you always go from left to right. But when you're solving, which is what we're doing here because we're solving by square roots, you kind of work backwards through them. So the first thing we need to do is get rid of any adding or subtracting that's happening in our problem. So in this first problem, there is no adding or subtracting to get rid of, so we're going to move on to our next step, which would be getting rid of any multiplying or dividing that may be happening. So right now, I have 5 times x squared, which means I need to get rid of multiplying by 5 by dividing. Once I've done that, I can move on to getting rid of the exponent, which is the squared. So we undo squaring something by square rooting. Now you may remember when you first learned about this that taking the square root of a number actually leads you to 2 different solutions, the positive and negative of the same thing. Because 5 times 5 gives us 25, or negative 5 times negative 5 gives us 25. So in this case, I actually have 2 solutions. X could be 5, or X could be negative 5. Generally speaking, for almost every single case, you will have 2 solutions. Let's try a little bit more challenging version of this problem. So, order of operations, I get rid of any adding or subtracting I can get rid of first. So, the first piece I see adding and subtracting is right here, this plus 1, but I also see it in here. Now, since this piece is inside of parentheses, which is the very last step that I can deal with, I can't touch that minus 2 until I get rid of the parentheses. So for now, I'm just going to move the plus 1 to the other side. And then I can get rid of any multiplying or dividing, which is the 3. And now I can get rid of my exponent by square rooting. And doing that gets rid of the parentheses also. Don't forget about your plus or minus. My last step now is to go back to the beginning because I made it all the way through my solving and I'm not done yet, that means I need to go back to the start, back to adding and subtracting, and work my way through again. Now this is the part where I see a lot of students have trouble, is that they'll try and just add this right in right away, but it needs to go in front of what you have. So we have 2 from this, plus or minus 2. So my two solutions are 2 plus 2, which is 4, and 2 minus 2, which is 0. One more time. So order of operations, I get rid of any adding or subtracting happening first. There is none outside of parentheses, so I need to move on to multiplying and dividing. Technically, you can get rid of these two things in either order. I like to get rid of the dividing first just because I think it makes a little bit more sense. So I'm going to multiply by 6. And then divide by the 2. Could you do them at the same time? Absolutely. Then I'm ready to square root. And finally start the process over again by moving the 1 to the other side. So -1 plus or minus 3 gives me 2 solutions. -1 plus 3 would be 2, and -1 minus 3 would be -4. So that's solving by square roots, is just following your order of operations, or what I like to call brute force algebra, just kind of forcing your way to a final answer. The next most useful one that we talk about is solving by factoring, where we're talking about this case with the little stars by it, where there's no c value. So, solving by factoring with no c. When you're dealing with these types of problems, it's actually faster for us to look for things that we can factor out of both pieces. And what I mean by that is we're looking for common factors of our coefficients, and then a common number of x's. So in this case, I'm looking for a number that both 6 and 18 would be divisible by. Now you may have said 2, you may have said 3, but they're actually both divisible by 6. So I'm going to pull the 6 out front. Now, what I have left is what times 6 gives me 6x squared, which would be just the x squared. And then what times 6 gives me my 18 back, which would be 3, and then the x. Now we're not quite done. Technically, if you were to write out this expression a little bit differently, this is x times x plus 3 times x. Now both of these have an x in common that we could also factor out of our expression, which would leave me with just an x and a 3 on the inside. So that's factoring where we're not using the box method. I'm going to try that again. So, new problem. First thing I want to look at is there something that both my coefficients are divisible by? And they're both divisible by 1, but that's not very useful. So that takes care of this first step that I did here. Next up, I'm looking for, are there any x's that I can pull out of both pieces? So both of these are divisible by 1x, so I'm going to pull the x out front, which means that there's 1x left of that piece, and the 7 left from that piece. Now, in order to finish solving these types of problems, because we're not actually solving yet, I'm just factoring so far. In order to solve them, what you're looking for is what makes each piece of the problem with an x in it work out to 0. So what would x need to be so that 6x equals 0? Well, in that case, x would need to be 0. Over here, what plus 3 would be 0? So that would be -3. That's how we get our two solutions in this case. Over here, if we try that again, what makes this piece work out to 0? Well, if x is 0. And what makes this piece work out to 0? What plus 7? That would be -7. One last time. So, looking for a common factor of 8 and 6. Those would both be divisible by 2. So 2 times what gives me the 8 back? That would be 4. And 2 times 3 would give me the 6 back. Now I'm going to go through and see, is there a common number of x's I can pull out? Which there is. I'm left with 4x minus 3. Okay, so what makes the first piece work out to 0? If x is 0. Now the second piece can be a little bit more challenging. What times 4 minus 3 will work out to 0? So if you write it out, you can just solve. So 4x equals 3. I added the 3 to both sides. And then I'm going to divide by 4. So solving by factoring when there's no c is just kind of reverse distributing is kind of how I describe it to myself. The last type, factoring, we'll cover in another video. So when we're talking about factoring with the box method, that'll be in a different video, as well as quadratic formula. So just a refresher, solving by square roots means following your order of operations kind of in reverse. Solving by factoring with no c value is like reverse distributing rather than using the box method.